Good morning, sir. Myself Manisha. Now I am studying BTech first year in CSC department, and today's my topic is matter waves. Outlines of the presentation. Introduction to matter waves, historical backgrounds, wave practical duality, de Broglie's wavelength, properties of matter waves, quantum mechanics and matter waves, and experimental evidence, applications of matter waves, physiological implications, and conclusion. These are the outlines of the presentation. Now coming to introduction to matter waves. Matter wave refers to the wave-like behavior of particles as described by quantum mechanics. This concept is rooted in the de Broglie's hypothesis, which states that all matter exhibits wave-like properties. Matter waves are fundamental to understanding the dual nature of particles, de Broglie classical and quantum physics. And coming to historical background, the concept of matter waves was first proposed in Louis de Broglie in 1924. De Broglie's theory revolutionized the field of quantum mechanics by introducing wave practical duality. This idea was later experimentally validated through electron diffusion experiments. Wave practical duality. Wave practical duality is a cornerstone of quantum mechanics, illustrating that particles exhibits both wave and practical characteristics. This duality is exemplified in phenomena such as interference and diffraction, which are typically associated with waves. The dual nature of matter has profound implications for your understanding of reality at the quantum level. And coming to de Broglie's wavelength, the de Broglie's wavelength is a key concept that describes the wavelength associated with a moving particle. It is given by formula lambda is equals to h by p, where lambda is the wavelength and h is the Planck's constant and p is the momentum. This wavelength becomes significant at the atomic and subatomic scales, influencing. Coming to properties of matter waves exhibit properties such as interference and diffraction similar to classical waves. They are characterized by their wavelength, frequency, and amplitude, which are related to the particles' momentum and energy. The behavior of matter waves is governed by the principles of quantum mechanics and wave function theory. Coming to quantum mechanics and matter waves, quantum mechanics provided the framework for understanding matter waves and their implications. The wave function, a fundamental concept in quantum mechanics, describes the probability amplitude of particles' position and momentum. Matter waves changes classical influences. And coming to experimental evidence, experiments such as electron diffraction has provided strong evidence for the wave nature of the matter. These experiments demonstrate that particles can create interference patterns akin to light waves. Such findings have led to the predictions for quantum mechanics and de Broglie's hypothesis. Applications of matter waves. Matter waves are integral to technologies such as electron microscopy, which leverages waves properties for high resolution imaging. They also play a crucial role in quantum computing, where quantum bits rely on superposition and entanglement. Understanding matter waves has implications for developing new materials and advancing quantum technologies. Coming to physiological implications, the concept of matter waves raises profound physiological questions about the nature of light and observation. It it changes classical notions for determinism and locality, introducing concepts such as inter- entanglement and non-locality. Physio- Physiographers and scientists continue to explore the implications of wave practical duality for our understanding of existence. Coming to conclusion part, matter waves represent a fundamental aspects of quantum mechanics that reshapes our understandings of the physical world. The properties of matter waves, including wave particles, durability, and interference, have far researching implications across various fields. Continued research and explore into matter waves will further unveil the mysteries of universe at the quantum level. Feel free to adjust the content or format as needed. Thank you. Presentation by Manisha, CSC Department.